Hi, my name is Amy Perfors, and this is a pre-recorded talk for the 2020 International Conference on Cognitive Modeling. I'll be talking about theory generation and how it's hard, and none of the theories we have are good enough for what we need them to do. So the starting point here, I think for me, like many, was the replication crisis, which made a lot of us revisit the processes that we go through as scientists and researchers. And one of the causes that people pointed out of the replication crisis is that researchers have too many degrees of freedom, not just in statistical analyses like in this XKCD cartoon, although that, but also just in, in everything, the tasks we have, the measurements we do, the many of the choices we make. And one of the solutions for this degrees of freedom problem has been pre-registration. And the idea behind pre-registration is that it both documents kind of the garden of forking paths that we're presented with, but also prevents us from just traveling down them and picking out the sort of few that seem to show a good result. And that's, I think, intuitively quite plausible and reasonable, but as others have pointed out, it doesn't actually necessarily solve the problems of researcher degrees of freedom, and it may impose costs of its own. So some of the reduced flexibility may be illusory because it doesn't actually remove flexibility from theories. And also, it might reduce our ability to do important things like, say, proper data analysis for the data we have or exploration. So one of the solutions proposed has been that, if we have strong theories, we don't actually need pre-registration. The idea is that a strong theory will clearly state the implications and predictions. So it doesn't matter if you were tested before or after you've, run the data. Then the theory constrains it. You don't need pre-registration. And I think this is also, very intuitively sensible. The thing that I'm going to be asking in this talk is whether that actually works in psychology. And there's three parts to my talk. First is I just want to sort of make sure we're all on the same page, talking about what characteristics a strong theory has. This is going to be probably not much novel, but I'm bringing together points made by many other people. The second part, I think, is the key bit of my talk. And what I'm going to argue is that I don't think we have anything in psychology that has those characteristics, not all of them, and that there are good reasons for this. And so I'll conclude in part 3 with talking about what implications that has for how we do science. So this first part, what characteristics does a strong theory have? Again, I'm sort of pulling together claims from other people that I also think make sense, and there's 5 of them. So one of them, I think, is that a good theory should systematize otherwise disparate elements. I think by that, the theory of gravity is actually a great theory because in the same theory it explains how planets go around the sun and why an apple falls from the tree. It has that characteristic. Another thing that I think good theories should have is a very Popperian view, but it should be falsifiable. That is, it should make clear predictions and not be able to explain everything. It should be hard to vary, in other words. Because if it can explain everything, then that's not a sort of useful theory. And it doesn't, if it doesn't make clear predictions, the same thing. Third, I think, and this is kind of related, but separable, is that it should be clear about what elements of the theory are core and what are ancillary. So the core elements are the ones that if they're falsified, the theory dies. The ancillary elements are the things you need to do in order to instantiate it, but not necessarily if they get falsified, the theory isn't necessarily killed. And a good theory should be clear about which is which. Otherwise, that's a problem with number 2. A good theory should also provide a link all the way between the data and the theory. That is, there shouldn't be gaps in explanation. You should be able to know how to get from the data to the exact prediction made by the theory. And finally, I think a good theory needs to generalize interestingly beyond its original domain. So evolution, the theory of evolution is a great example of this. It was originally about phenotypic variation like beaks and stuff. It predicted that there should be something like DNA that was responsible for this, and lo and behold, there was. So it should generalize. And again, I think this is true for psychological theories. Now, given these kinds of constraints, many people have argued, and I've been one of them, that strong theory probably requires something like formal modeling. Formal modeling requires you to make assumptions explicit, It makes predictions much more precise and often in unintuitive and non-obvious ways. And for that reason, it's a really key tool in our toolbox. All right, so given these characteristics, the question is, does psychology have theories with them? And I'm going to argue no. And the reason I'm giving this talk in the first place is that I was thinking about this, and then I was trying to think about how you could go from, a theory to actually constrain our degrees of freedom in that way. And I realized I couldn't figure out how to do that, because I couldn't figure out how to do that for any of the characteristics or any of the theories that we have. We don't have anything that satisfies all of these. So just to sort of, get into it, as I was trying to figure this out, I was trying to think of, well, what is a theory that would give us these properties? And so I thought of some of the best theories we have. None of these are strawmen. These are actually some of my favorite theories, why I'm in cognitive science. I've done a lot with them. I'm going to focus on these three here, mainly because I know them better. And again, fingers pointing squarely at myself as much as anything. But I think my points are going to generalize to, any of the theories that we have in cognitive science. Like I said, I think these are the best ones we have, the most formal, the most widely attested, and the most replicated. All right, so let's just see, do they actually meet our criteria? So I'm going to lump number 1 and number 5 together because I think they're kind of similar. Do they systematize other elements? Do they generalize interestingly? I think they do, actually, all of them. So Shepard's law of generalization, which says that, generalization is an exponential based on the distance of the stimulus. I think that does generalize. It's to different kinds of formalisms, more data points, and so forth. The generalized context model, which has to do with categorization as a function of similarity, it generalizes to other types of formalisms. It's very similar to kernel density estimation and also has a lot of empirical backing. Bayesian models of cognition, there's lots of deep similarities between them and information theory, even formal models of evolution. I think all of these things work. The problem comes when we consider some of the other characteristics. So again, I'm going to lump these two together for reasons of time. Do these theories make clear predictions without being able to explain everything? And are they clear about what core versus ancillary elements are? I don't think they are. So let's take the law of generalization. It's actually the best of them, as far as I can tell on this. But even it basically has similarity as a kind of unanalyzed primitive. In order to generate the space, you sort of basically rely on similarity judgments. Similarity judgments aren't part of the theory, but you need them to make it work. And it's not explained. It's an unanalyzed primitive. And moreover, just the fact that MDS representation also makes certain kinds of assumptions about the structure of that space. So, certain ordinal relationships between the items have to be maintained and has got a certain spatial structure. So they're not huge, but even so, there's this part of it that sort of on which the precision depends, but that is not technically part of the theory and isn't really explained. The generalized context model has all those problems with similarity, but it also has these additional problems which, at times it doesn't necessarily match human behavior. You can add parameters and add things to the model. That's fine. Again, every model we have has those problems. But then it starts to blur the line between what's ancillary and what's not. And, to what extent is this actually falsifiable? And Bayesian models of cognition have this problem quite a lot. In fact, I actually would argue that Bayesian models aren't a theory themselves. They're a framework for exploring theories. The theories themselves are the hypothesis spaces and likelihoods and so forth. Not everyone uses them that way, though, and the rhetoric isn't always like that. And even if you're doing that, they're not often, juxtaposed against each other. So you're not actually comparing hypothesis spaces in that. And there's a lot of ancillary assumptions you have to make about how those spaces are searched and so forth that aren't necessarily part of the theory, but are part of needing precise predictions. So basically the problem is the precision of our computational theories, which is argued to be the strength, and that is why we need them in order to constrain our choices, often comes from these ancillary elements, not the core ones, and thus sort of you can't falsify them that way. And this is a big problem. Now, one possible solution you might think is, and this is what I thought, is maybe you could just integrate over all the possible auxiliary parameters. I don't think that's a good solution for several reasons. One is it's just not feasible. There's, potentially infinitely many things. No one actually does this, even close. But secondly, there's a problem for a no free lunch thing. Like, no theory is going to work for all possible sets of auxiliary parameters. Some of them they're going to do badly for. The thing is, we only want to sort of care about the ones that are important, but there's no theory neutral way of defining what's important. And finally, if we say make the auxiliary parameters part of the core theory, there's even a problem in sort of choosing what those are and doing selection among them. So this is actually a big problem. We don't know which assumptions we need to worry about, and we can actually vary those assumptions. So I don't think these follow that. And finally, there's another fundamental problem about linking between from the data to the theory and back. And this is a problem of measurement. What is similarity? What is belief? In psychology, we have this very, very fundamental issue. I think it's not an accident that we have mathematical and computational models where this issue is less, like in psychometrics, where the measurement is key. And we don't have many in social psychology, and I think that's a really good reason, because it's even harder to measure those things. Even though in things like psychometrics, we often buy precision as at the cost of generalizability or interestingness, and we begin to model the task rather than the people. And that is a very big problem too. So the measurement issue is huge. So basically, I'm going to say we don't have strong theories, strong enough to constrain our choices at least. They're, not both falsifiable and interesting. This core versus ancillary distinction is hard, and the measurement problem is big. So what do we do? If we don't have strong theory, how do we get it? I'm going to argue that this is the question we should be having. How do we get strong theories? And that's what leads me to part 3, which is we need to think about what incentive and structures and processes will help us generate and build good theories, not just test them, which is what the focus has been. So what I'm going to argue is that theory generation and construction, it's very hard. You can't set up an algorithm for it. And moreover, it works really in tandem with measurement and testing. So what we need to do is have much more incentive for good measurement and testing of those measures, and less worry about theory building. So measuring things in a variety of ways, validating them in much more widely than we do. And then I'm also going to argue that almost certainly restricting ourselves to just a few ways of doing science, an algorithm, is going to be counterproductive. Nobody should be doing the same thing. We shouldn't all necessarily be pre-registering, but we also shouldn't necessarily all be computational or mathematical models. We should not put each other in boxes. We should do lots of different things because we don't know what the best thing to do is. I'm sure of almost nothing, but I'm sure of that. And so what we need to do is incentivize good exploration and not adherence to a formula like we should all be modelers. That doesn't mean we don't have standards. There's a lot of things on this slide that I think we can do as a science to make sure that we're doing good science, making people document things, foster a culture that makes us look at data and analyses, making them open, foster a culture where we test many different versions of theories and ancillary assumptions and so forth. But the thing that we don't want to do is say we should all pre-register, or that we should all sort of be cognitive computational modelers. Instead, we need to say, how do we get to better theory, not say we can't do anything until we have strong theories, because frankly, we don't have strong theories. So in conclusion, I guess all I'm saying with this talk is that, science is really hard. And to quote a really great paper that came out recently, simple fixes to complex scientific problems rarely exist. And those simple fixes include the suggestion that we should be doing computational modeling, that computational modeling sufficiently constrains our choices as researchers, that that's our solution. That is one of a mix of possible solutions, but I think its benefits have been touted far more than I'm comfortable with, and the problems have not been focused on as much. All right, that's it for me. Thank you.